So I just said, I mean, I will upload the assignment 3 there. That will be doing your LISO. And you do the regression tree and the random forest. Okay. I don't know if I have updated the slide. I mean, if you later can check out, I think I did, but let's see if I update the slide. There. It's not loading. So I think it's more update version, which I show you I think in the better code and better changes. But if you haven't download, maybe you can download the more update version. Later you will see the probably you would want to see how the, say in particular, I show the how when you run the regression tree, right? Say the random forest. When you run the random forest, this is the regressor there, and then it can be shown how you will feed multiple trees. One tree is like this. You will treat this tree and the other. Depends on the data, right? So if you remember what is the random forest, right? So in this case, you have x1, x2, different y. Random forest, I mean, the data we just you bootstrapping the data, right? And then you will decide an estimated number of tree you get, and then at the end you will get 3 different tree, and different tree will be different because depend what kind of data you get. Say in this case you have 4 sample, in this case 3 sample, the other case 4 sample. So every time we try to every tree can be a little bit different. Okay, so you have multiple tree and then you average out the prediction. But if you time, you can take a look at the new updated slide. But I guess you need them when you do the assignment. So that would be the thing. I think I already make the exam questions. So similar to last year. I mean, some little bit the multiple choice slightly a little bit more difficult, and slightly. No, sorry. The multiple choice is actually easier. I think in the sense that, I mean, I guess if you don't have calculator, doesn't really matter. And the long question, yeah, I don't think you may not need calculator. I mean, if you're able to take multiplication and addition, just standard, very simple thing. I mean, if you have primary school math, then it should be fine. And maybe you want to bring calculator if you want to, but otherwise it shouldn't be an issue there. And the long question will be, I think this year I only have 3 long, maybe just 3 long questions is therefore, so 1 question less. But should be, as I said, I mean, on average, you are not supposed to finish everything. I have more questions than you can finish, but I want to see who absolute A is very clear, so I want to see that. But otherwise, I mean, you don't really worry about that. So next class we will do a presentation. So as I said, everyone will have 2 minutes, right? No matter if you have 4-person group, you have 4 minutes. So that means that you present the very best part of it. Okay. And then everyone expect to say something in the group. Okay. Not delegate to one guy, because I will give grade to everyone for presentations, great. And also I think you guys can vote for the best presenter or best group, then they get extra credit for that. Okay. So that would be something we will consider. I mean, you can tell me what kind of prizes you want, then I can get extra credit for those who are voted by the group. Okay. And next, as I said, I want to, in case of any questions, just let me know, because this last class, so basically I'm not going to go into very deep, but rather I would just try to give you idea of many things we can do. I mean, probably I will not go to the Python code because of the time, but rather I would try to give you the idea what we're doing, right? Because this year I think we're slightly behind the schedule, so but it's okay, because of the last two chapters are basically what we call the identification question, where we want to discover the causality, the causal effect, right? Whether X actually causes Y, and we don't care about prediction. So when things are in the regression equation, or you include in the explanation, have to make sense, right? It has to be case actually there's something we want to understand. So in order to do it, the method we do is we have to have a framework to understand what's going on. So we have some story there. So this is the part where we have the domain knowledge. We have to understand economics, understand how people behave, or we understand how the business sense, right? Where the business comes from, right? Before, so far, we don't have anything about business, right? We don't really need anything about how people make decisions, and all the theory is gone. But from now on, if you understand how people make decisions, we need to go more than data. Okay, we have to make some assumption in order to do it. So the idea is that, right? Is the Y is the target, right? Or the outcome variable, and X is the treatment, the causal. And then we want to see Y changing X to changing Y, right? Because in the previous case of prediction, it doesn't say anything, right? Maybe Y cos X is also possible, right? For example, in the car prediction price case, right? If the price is higher, probably you maintain the car better. You drive less, right? Who knows what? But right, there's a things can go the other way around, right? The standard thing, right, is like education income, right? People who go to master or tend to make more money, right? Is it the education makes you earn more, right? So after now you do the ITM master, after next year, right? Next year you are done with the master degree, you graduate, then probably your salary goes up. And the question is it the master is the reason, right? I hope so, but is it the case, right? If you actually see the data, actually those people who graduate from, say, M.B.A. or master usually have the much higher salary. Is it that case? It's not. It's unclear, right? Because of there are several reasons, right? One is maybe the admission officer is very smart, right? Basically, they're picking the guy who is bit smarter. So this just because you select smart people, of course, you end up in better, right? So we don't know, right? Or it may be the case actually, people who are more hardworking, right? Actually, would more ambitious will go to the master program, and at the end they get higher salary. That's normal. Even if they don't go, they can, right? So you have to compare the counterfactual. So that is very important. You have to think about those. So that would be the thing. But when you in experiment in the lab, you don't have this issue because you can control the guy to do what, right? So you can put different people in different treatment. Then okay, you decide who get what. That's okay. But in the reality, it's hardly the case, right? It's not that easy to put randomly assign people because it's not ethical, or there's some issue here and there. But that would be the idea. Okay. So so that's why we have to compare counterfactual. That's why in the literature they would call what call the potential outcome framework. So the outcome you observe is called YI. Okay. And if you impose some treatment, maybe you ask them to look at the new interface of the website, or you put in something changes, right? Cause and effect, right? And this is YI1 is if the treatment you 1, if nothing is 0. Okay. But the problem is at any point of time you only have 1 or 0. Right? You cannot have both at the same time. Right? So if the guy would have medicine or no medicine, right? You can have both at the same time, right? At the same point of time, you either have this or that, right? Because the different point of time is different. Okay, so this is the problem. So we have to, because we only care about the difference of the treatment, so that would be difficult to do it, right? Because say suppose I take a medicine or take a nutrition supplement, right? And I become stronger, okay? But you don't know if I will become stronger without taking that. You don't know, right? So suppose there are simple cases. There's a beautiful lady there, right? Suppose I bring a very beautiful flower and she's impressed, right? But you don't know if she is impressed without the flower, right? So it's you don't know that point, right? There's a different universe. You can see it, but there's only one chance. The first time I saw her, she may be impressed by the flower, okay, red rose, okay, or maybe she will be impressed by some other thing, right? We don't know, but you have to try. Only try. You can try once, right? There's only one chance at lifetime. You can try whether you get it or not, right? Suppose like this, right? You want to see if you don't do revision, right? You don't study this class, we will still get an A, right? And you can only try, you study or you don't study, right? You cannot say I study and I don't study, right? There's only one chance. Okay, so that's a problem. So that's why this is a framework like this one. And as I said, the treatment effect is different, and we only have one or two. So that's a problem. So we can't really do things, right? So how can we know, right? Just like the vaccine, right? The COVID vaccine. Either you take it or you don't take it, and then you see whether that guy get the disease or not, right? Then you can see whether they get it or not, and then see whether they got the disease or not, right? Extra treatment, but you really can't have simultaneously you have or you don't, right? Either you have or you don't, and that's an issue. Okay. And the important part is it really depends on the treatment effect, right? Whether the guy have vaccine or not, and whether he has disease or not. The problem is it really depends on not just the treatment you do, but also depend on the guy, right? If you inject a vaccine to a healthy guy or an unhealthy guy, it's not clear, right? Only if you can control they have the same condition, then you can do this. Okay, so that's very important. You have to make sure that you compare the control group and treatment group have to be the same. But that would be the main thing. Okay, so that's why when you look at the literature, and that's what we want to do. We want to look at the average treatment effect because we really don't know. You can have the same guy, right? So what the hope is, we're going to look at this expected treatment effect, right? It will be the expectation of difference, and then because expectation can spread out. So what you want is, suppose people who got a treatment and without treatment are very similar. That is what you do in medical thing, right? So look at those people who get the vaccine, how healthy they are, and those who don't have vaccine, how healthy they are. If they're very similar, you can take a difference, right? Just like you want to see how is the income increase after you get a master class, right? They look at the people who take the master course and people who don't, right? If this is valid measurement, if people who were doing the master course is same as those who don't, right? If they're comparable, this is valid. So the main thing actually in the causal identification is to make sure that they are very similar so that you can do the subtraction. So basically, one easier thing to do is imagine I look at the people who just get in the program and who just don't get in the program. Then actually there's sometimes we call regression discontinuity or difference or propensity matching. So we just try to look at comparable group. Okay, or that's what we do difference. So that all the terminology here is basically trying to make sure that you can compare people who get a treatment the same. Okay, so that is the main idea. Okay, and this is what we want to get. Okay, but a lot of the time, okay, it's not that easy. Okay, and this part is sometimes that we can't actually find this guy. So and usually we don't have the way to do it, okay? And we can't compare and contrast. So because we don't have treatment group. So the only thing usually we do is treatment effect on treated. So basically just look at how much you make before the master student, how much you make before you come, and how much you make after. Okay, this is something that sometimes we can measure because we don't have the comparison group. And that is sometimes we only can do that. Okay. And if, of course, if you randomly pick people to take the master class, then that will be fine. That what you measure with the same thing. So that is actually what the science usually they can do there. Okay, they look at randomly pick up people from the world and just do something crazy, then that will be happening. Okay, so that means that if you are IT manager, all right, so you want to test something, if you randomly send out the test program, okay, you want a new software, right? You have new software, you want to test whether it's good or bad, right? See whether people more engaged in the system or what. In that case, you randomly assign to your customer and see how well they perform before and after, assuming before and after is very similar condition, then you're done, is fine. You should be able to randomly pick. But if that is not randomly picked, you can't. Okay, so that would be the goal. Okay, so now I hope I explained what they are, because if you don't understand this part, okay, that is very important, because the selection effect is very important, because what get treated and what get not, then it's not clear. Suppose, say, if you want to have a marketing campaign on online, right? And then you want to see this online is going to, say, attract new sales, suppose, right? And then you calculate the ATET, right? Because that's what you do. But you focus online, that means that you only have the customer that's online, right? But you don't have all the customers. So you have to actually pre-selected the data based on online customer. You forget the offline people, right? If you only care online, then that's no problem. But if you want to look at the offline, then you are pre-selecting the thing, then you're not measuring how affect your program overall. Okay, so it really depends on your research question, but I hope that it makes sense here. So here, first we talk about the data. You have to compare control group. Okay, if your data is not randomly assigned. Okay, and that's the first thing I mentioned already. The second important point is what to put in regression. Okay, this is the second point, is related causal map. You will tell you that, so in the prediction, you can put everything X there. If you like any X, you can put there. Okay, you can put whatever garbage, there's no problem, because the program, if it's a LISO or whatever, or random forest will pick up the one you like, and that's the best. Done, right? You can forget about things. You can put whatever in the kitchen sink and then come out, boom, then it's okay, right? The magic comes out. But you cannot do that when you do the causal analysis. You have to be very careful what to put in. So here we'll have a drawing some bubble map and then tell you what you put there, what to put there. But that will be something we make assumption. That will be the causal analysis. So the map will be like the circle, the notch, and the direct edge. Okay, that will be, we will have to draw labels and arrow and tell you that a direct graph is no cycle, a cyclic. So that will be telling you that how we think from our knowledge, whether A affect B and B affects C and so on and so forth. And then you tell us how to do regression. So that's very important. And the second point that we want to talk about before the break. So first is there's a average treatment effect, and then you have to compare something we haven't done, because we don't have these two data together. So we have to do the average one, right? When the average one, the problem is it's not comparable. Okay. And of course, if you pick up the treatment is random, then it's okay. But in general, it's not. So one of the main things that we learned today is how do you adjust to compare. But that will be the main focus today. And that will be how you run the regression, how to select the data. And the second part is what to put in the regression equation, right? Because the first one is looking at data. what equalization method you want to use. The second is how to put the x there, right? With the y there, but what's x there? Okay. So in the simplest case like this, okay. In this model, okay, is x would cos y. I don't know whether it's going to be positive, negative. I don't know. Okay. If only x cos y, there's no other thing. You know, there's only thing in this world. Only x change. Everything is control, not the change, right? Then we run the regression. You are done. Okay. The problem is really mainly is there's something else that's changing, right? You don't really know, right? Whether this thing at work or not. Okay. So that's the main problem. Okay. So the idea is if we draw the map, then we would know what to put in X. Okay. And we tell you different scenario whether to put X or not. Okay. So this is a graphic idea. Okay. So here is the following. First is we call a new terminological mechanism. Okay. Mechanism is a oval shape where x cos y through the mechanism M. Okay. And mechanism is how this affect x affect y through it. Okay. Let me give you an example. Do we have a good example there? Okay. For example, so y can be your income, right? And x may be education, right? Or IQ, right? And education actually improves your skills, right? Your productivity. You study and you know how to do regression, you know how to do random forest, right? And then you get high income, right? Say, right? So that is the mechanism it means. And that would be the thing we want to do. And I think we have the same thing here. Okay. So the next part is look at the variation source. That would be the main idea how to draw the graph and explain. Okay. So remember regression or the machine learning is I use variation on x to explain variation on y, right? Because that is what the regression is, right? How change in x, change in y. Okay. And there are three things, right? If there's a variation x that only affect x, okay, and there's a endogenous that affect both x and y, right? This is okay. This is a little bit problematic, okay. And if you want to establish the effect on x on y, you have to isolate this endogenous thing, and endogenous thing is something we have to care. Okay, so that is very important. So the first guy, exogenous, is fine. Okay, the only problem with the second guy, you have to rule out the second guy, then you can do the third one. So that is the main thing. Okay, so like this question. Okay, if z change x, x change y, okay, that is okay. This thing, if that is happening there, we don't really care, right? The IQ, how smart you are, may be determined by your genes. We don't really care. We don't have to put the gene in the equation. So it's not a matter thing. Okay? Or that would be the genes or your father, your mother, your ancestor. Doesn't really matter, right? Or how smart the monkey is, doesn't really matter. We don't really worry about that part. Okay? The only part is like this one, the Z2. That is a little bit tricky, right? For example, this is your parents, right? Parents, how rich your parents affect you, right? How smart you are, because how much money they spend on your education or food or whatever, right? And the genes, whatever. But the problem is also your father and mother affect how much you earn, right? If you are second generation of whatever, right? Then you immediately get treatment, right? So if you are second generation of Guan, second generation of Fu, right? Rich, right? second generation of official, right? Then you get better thing, right? So that part is difficult, right? If you don't have that in your regression, that's an issue. You don't control that, it's an issue. So regression is able to control it, right? So if you run the regression, you don't have to worry about this part. If you don't have this data, if you have this data, it's fine. Okay. If you don't have this data, that's an issue. If you don't control how rich you are, your parents are, run the regression, you're misleading, right? Because you cannot isolate the impact of your parents, right? Because, right, your parents may be very powerful, right? So maybe powerful parents put the kid to the master program, right? Then also make them make a lot of money. So you cannot say the education help because it's confusing, right? So it's confusing, you don't know. So as I said, exogenous is good and endogenous is bad. Okay. So good, we can exploit. Endogenous is difficult. Okay. So in this case, okay, if you run the regression later, you will see if that's the case, if I cannot control your parents' data, okay, but if I can look at your gene, which is maybe unaffected by this, right? Suppose, right? Then I'm fine. If the science tell me there's IQ gene there, suppose I have that, right? Then I run the regression on the income and to the gene, that'll be fine. Right? High IQ to the master program, and then that will be fine. Okay. So that would be the case. Okay. But later we see. Okay. So no, we said there's a 3 types of variation of X, the exogenous. So in the book, they mentioned there are 3 different types of way is variation. Okay, that is a nice thing. Okay, the first one is like control experiment, right? If you are IT manager, you implement this randomly by you control it, then you run the regression, there's no problem. Okay, if you are the one who decide who get what, then no problem. Okay, but if not the case, that will be issue. Right? Say suppose you have now we just passed by November 11th, right? The discount imposed by that is not random. It's not you decide, right? It's this is a day, right? So it's not you randomly put the day, right? If you randomly allow that, that'll be fine, right? So that is an issue. And the other is often used as a random experiment, right? It's something like the nature decide was X, right? And then you can see how things are different, right? Often they say earthquake, right? Or some crazy thing happen, right? Then you can see how people respond, right, to that, right? Look at the earthquake and say earthquake change people perception, right? That would be something that we can look at that, right? So say for example, you are IT manager, right? You want to see whether the internet connection is bad, how does it change your sales, right? Then probably you can't do things like this, right? But if this earthquake happens suddenly, right? No one prepared it, and then there's no internet connection, then you can see how this affect your offline sales or online sales, right? That is possible. Or that part suddenly have power outage, right? This area, then you can compare, right? That would be doable, okay? There is a lot of people doing research on that, okay? And another is condition, and that's very simple. If the variable X, you can control it, right? Look at, say, in the example I said, with the master program make more money, right? You control age, right? Usually people get older, have higher wages. So when you run the regression, you will control those, right? That age is not controlled by you, right? No one can control age, right? So that's okay. It's exogenous, right? Age is exogenous. So that would be fine. Okay. Or gender, right? Unless you are doing gender change, right? Gender is a fix, right? So that would be the case. Okay. So that means that if the problem guy is Z, this graph, if you control X by yourself, you are the designer, Then you run the regression, that's fine. They're done. Don't worry about anything because you decide how to do. Just impose it, then you're done. Right? So suppose you want to see, you run the regression, you want to see you implement new policy or new changes in your website or whatever protocol, whatever your JavaScript, you change it. Okay? You optimize it and you see how people react. Run the regression, done. Okay? That's it. Done. End of story if you can control. Okay? And the problem, right, of this is when it's a problem, okay? As we said, there's exogenous thing that Z affect both X and Y, right? So your parents' socioeconomic status, right, that affect X and Y, right? And the other thing is also complicated. Y will change X, right? As I mentioned before, master degree would affect income, right? But the problem is also that income change your decision to do master program or not, right? If you're rich, you're smart, actually you may have money to do master program, right? So you don't know actually is what costs what, right? Because you are maybe on a, maybe you go to master program because of this company sponsor you, right? You're very good already. So this, we don't know, we don't really know, right? It's a feedback, right? And that's what the unwanted mechanism, okay? There is a something that changes X affect Y, but also Z, okay? And Z also affect Y. So there is a unintended consequence, right? Maybe the following. You go to master program, okay? And then you met a rich white girl, right? And then you marry with her, then you make a lot of money, right? You 碰到高富帅白富美, right? Go to master program, right? Then you get a lot of money, right? So you don't want that happen, right? It did happen, right? When you go to a elite school, right? You met a prince or princess, right? They get married and then a lot of money, right? Right? Then who knows, right? That you have to exclude that. So that will be the idea. Okay, so I hope that make clear what's going on there. Okay. So the problem is this guy, right? So there's a co-founder, right? Is affecting the two. So we want to control that. Okay. And so there are three types, right? This affecting both, as I said, is the parents' genes, right? Or parents' socioeconomic status, right? This affect this one, right? And then it might be the case that you got the master program, you get more money, you got a PhD program, you got a second master, so on and so forth, right? So we really don't know. I mean, that's a little bit more cycle, right? And as I said, this is you met the prince and princess in the program, right? So you make more money, right? So who knows what? Okay. So the very main thing actually, very often when we run the regression is we don't have enough data, right? In the real world, it's just like more promise. If we have all the data in the world, we can always do whatever we want. The problem is we don't have that data often the time. So that's why we don't have that data. Okay, the confounded is Z, right? Something is affecting, we cannot control that part. It's not observable, all right? And or these are imperfect measurement, okay? Or the bias that's a problem. So the omitted variable bias is you miss the data, right? Remember when we run multiple regression, right? Compared to single regression, that you miss the data, that is different, right? Because remember the example of the car, right? With the age and mileage, right? You miss that will be very different. Okay. So here now we come after we see so many things. Now we want to tell you what should be in X. Okay. We tell you that what. So here we tell you what shouldn't be in X. Okay. The three things shouldn't be X. Okay. You should not put variation, extraordinary variation of X in the regression. Okay. I'll tell you more. The mechanism variable and collider variable. So what's that? I mean, let me tell you an example, then you will see these should not, you should not put everything there. Okay. For example, as I said, you want to study how master program affect your income. Suppose you run this regression, right? You collect all the data of the income of the student graduate from this program and look at, right, the student whether we get it or not, right? Whether they get a master program or not, right? And the question is, do you want to put your IQ in the regression? The answer is no. Because assume the model is if you're smart enough, then you do the master program, right? Why you want to put that? You want to put it there, then you will, if you put there, you cannot identify this one because this will have some effect on this one. So when you run the regression, you will have, they will multi-collinear, right? They're related. So your coefficient will be very small. So suppose you run y on x and y on x on this one, then this will be positive. Okay, let me write that down because I think that is important. Because that is important, so that's why I need to talk a little bit more on this one. So suppose this is whether you take the master program, right? Take or not, right? Yes. And this is your income, all right? And this might be your IQ, right? Suppose IQ determine whether to do the master, so very in this model, right? Maybe IQ is not good. Maybe anyway, I mean, suppose this is the case, okay? Maybe this is not the best example, but anyway, suppose this is the case, right? So when you, this is the Y, this is the X, this is the Z, right? So if you, the thing you should do in this case, if you draw this, you should run this regression. Then the beta is done, okay? If you run this regression, then that's a problem. So if you run that, you will be wrong. The reason is because X and Z, they're related, okay? So if you include this guy, this will be much smaller. So you identify the you will wrong thing. Okay. So if that is the case, then you should really forget about it. Okay. And the second case, so that means that you should be, when you're able to, then of course the question is, how did I draw this diagram, right? Come from your domain knowledge, come from your theory. You think which one is right, then you can do it. So that's why every time when people talk about causal analysis, they will ask your identification assumption. They ask you why your regression or why your analysis is going to tell us they are causally related. You have to tell them, okay, this is my story. I think this caused this and caused this, so that's why I don't control that. Okay, we can argue on whether this is right or wrong, but that would be the idea behind. Okay, so this is and the second one is also like this. Okay, if you do the master program, okay, and you put random forest here, right? You learn random forest, right? And then you get higher income, right? And again, the same idea. You shouldn't put random forest there, right? So maybe you collect a lot of the data that have different master program, right? Some master program have random forest, some doesn't don't, right? And there's income there, right? And you shouldn't put things in there, okay? Because again, the same idea there, right? They're related. If you put in there, you are fail to you fail to attribute the beta, so you underestimate it. Okay, so that means that whenever it's in the middle or before it, rated X, you should forget about it. Okay, you shouldn't include them. Okay. And the last one, right? You got the master program, you got your income, right? And this is how happy you are, right? Maybe, right? You get, I don't know whether it's positive, negative, right? And then you shouldn't include how happy you are, right? The reason is because they change together, right? So you control that, then you also don't know which part is moving, right? Because both affect them. Okay. So you should also ignore them because you really don't know which side going, so you forget about those. So these are the things that tell you what you should put in the regression model, right? So these are the cases where you shouldn't put in the regression model. Although you have a lot of data available, you shouldn't put all the data in. Okay, and will tell you what to be there. I hope it's clear. I mean, of course, as I said, if you want to become an expert on causal analysis, require PhD. But I'm just telling you the general idea, how to put X or not. But this doesn't require PhD, right? Everyone can do it at the master level, right? The technical skills require that, but the simplest one is just like, okay, what you should put in X, what you shouldn't, right? And for IT manager, that's easy, right? Because you can always easily change the X by yourself, right? That will be fine, right? Because like this, right? You decide change the program, right? And this is your boss, okay? So you shouldn't put the boss in the regression, okay? Your boss is asking you to do the changes, right? Boss A asks you this, boss B asks you to the other one. This one should not be there. Okay. I hope that made clear what it's about. So don't worry, we go to example and tell you what are they, okay? And we'll go to the example. So the idea of the causality, we said there will be 3 different types. If you do control experiment, that's what we do. IT manager is good. If you rely on natural experiment, that will be okay. If you condition, that will be you are not certain. Okay. So the problem is the causality have to think about generalize. Is it you generalize from past to future, from one market to the other, from one country to the other? So that's very important. Okay. And probably if it's a good before the break, we go to this example, okay, then will be important, right? So we want to look at health and food. I guess if everyone noticed what happened in the US election right now, that's important. It's MAHA, Make America Health Again. That's what happened now. Is you eat the food is very important, right? Actually, you are what you eat, right? So you can see I'm a little fat, so it means that I do not eat very healthy when I was young, but I hope you do eat better. We want to prove this, okay? This is our proof is some kind of food make you healthier than other food, okay? And in particular, you want to see whether eating fruit and vegetable avoid high blood pressure, okay? So it's very tempting. You just, okay, the easiest thing is what? Pick up a guy, very similar, give him vegetable, give him fruit, and the other guy, give him all the meat, okay? And then compare, then you're done, okay? Okay, this is doable in the Asian world, right? Now we are civic society. We cannot pick someone and do it. We can do it to animal, maybe do it, but to a human, we cannot do it, right? It's very hard, right? It's very hard to do it, okay? So that is how we are going to do that, okay? And this is the main thing, right? This is the causal map, okay? And fruit and veggie, is it going to lower the blood pressure? That's a question, okay? But the problem is whether people eating fruit and veggie, is it going to, because the stomach has limitation, right? You feed them more fruit and veggie, means that they can't eat unhealthy food, right? And unhealthy food probably will have impact on blood pressure as well. So this is unknown, right? And you look at people who eat more veggie, maybe actually they're more health conscious, they care about more health. So this part I don't know, right? If they're conscious, they have more healthy lifestyle, they have less healthy food, right? So that will get here, right? Or because you have high blood pressure, you got a doctor there, right? And you go to here, right? That's a reverse causality, right? Just go back, right? And also whether you like the taste of veggie and fruit, then you go to here, right? And whether you are rich or poor, right, will affect whether you eat veggie, because veggie in the US is very expensive compared to meat. I mean, I think it's a different case in China because we have so many land, right? So many veggie, right? That would be the idea, right? So that would be the case, right? So the question is, this is the map. Again, this map come from your head. Okay? Of course, come from other historical data or historical study or understanding, and this is the map. So the question would be, this is the map. We only have these two data, or if we have everything there, what should be included? What shouldn't? Okay. First, should taste be included? Yes or no? Who say yes? Who say no? Good. Taste is only affecting this one, right? So taste is actually the exogenous variation, right? So you shouldn't include, right? And doctor advice is what? I think, do I have the answer? If I answer, then what I'm asking will be nonsense, right? So the doctor advice, so you can include them. How do you control, right? And right, this, so you control this one. So you control, look at, they eat the data of the blood pressure, the data how much food they eat. So you control how unhealthy food they eat. This is, if you forget about this, if you just focus on this one, because make it easier. Suppose the graph is only this one, right? Make it this case, okay? Only this one. Only focus on this part. Should you include unhealthy food? You should. Okay, so let's look at this. Let's see whether you should or not. So this, right? So go back to here. Should you include or not? No, right? This unwanted is a mechanism variable. You shouldn't include that, right? Because you eat more healthy food, then you eat less healthy food is already there. If you control that, then basically you underestimate the impact. Okay, if you of course there's it here, but I mean that is the thing, right? So that is a little bit complicated, but I hope it's clear. Give you some idea what should be there, what shouldn't be there, right? And is that clear what we're doing, right? So here's the data. Okay, go back to this one. How you can do it? I mean, quickly we do it. Maybe 5 minutes and a break, right? So there's a question about a survey, right? Look at how much they consume and look at the blood pressure, and then they do how did they get it, and then the US data, 7,000 data set, right? And this study, this the mean, and this median, whatever data you have, right? Whatever, doesn't matter. And this is the graph we have, right? So look at the scatter plot, right? And at least from a diagram, you will see, right? Very optimistic, you get more vegetable is going down, right? So hope that is right? And I think this just you do a more the line only, just the same thing, but the scale is a little bit scanning. But this is the correlation there, because regression only shows correlation, right? And if you look at income as well, where you see, right, you have higher income, you eat more veggie, as I said in the beginning, right? You have money to eat veggie because veggie is a very expensive thing. If you eat organic, then it's more expensive, right? And then also people who actually have time to exercise, they're more cautious, right? Then the more healthy lifestyle, then they eat more veggie, right? So, and in the US, right, people eat chips, right? So if you actually, you can see people who eat more chips eat less veggie, right? And but can be go other way around, right? You eat more veggie, then you eat less chips, right? Because your stomach is fixed, right? So it's a common cause, right? So it's we just seen there, right? Healthy food. So you shouldn't control these potato chips. Okay. So I think in the after the do I continue to do that? Oh, not in this one, but you can check the textbook. They discuss how you would draw this map there. Okay, and these are data tell you up to be there, right? So if you run the regression, you forget about this. We talk about how to control the above, but we tell you that you shouldn't have that one. You shouldn't have that one, and this one is very complicated. Okay, we have to figure out how to do this one, but at least this shouldn't be there. Okay, and how to handle this thing, we talk about that after the break. But I hope it's clear what we're doing, right? So there are two things there. One is what you should put regression, right? When you really run it, you want to do causality. The second is how to handle data, right? Because you need to make a valid comparison, right, to the data. So you want to look at this guy, and you have to make the two group is comparable. Of course, if the data is already there, it's fine. If not, then we have to make way to make comparable. So, but let's see after break, and then maybe in the meantime, I just open the U reply. You can tell me how well you're thinking, and do remind that this is the last class for me. I mean, next two will be yours, right? So if any question, please feel free to write that down. I mean, we don't have to finish everything for the causality exercise because I showed the causal map, so the potential treatment framework, I think already done. I mean, of course, the other are just technical things. Okay, already tell you most of the stuff already. So you can tell me how well you're doing, and leave any question if you want to know, and otherwise enjoy the break. So we'll resume 15 minutes later. So we will be 15:49. So we will resume that. So I see you then. I'll go around to see if any question you might have. 可以选吗？不用干了，是的。对，这里就是吃东西很对，西瓜了，对西瓜了，我就被西瓜了，不能带西瓜，我不能带西瓜。
能不能25考过啊？
哎，不错啊。看看你。
我的这边也太臭了。看下面那条边。
不错，还喜欢。
哦，我
很好的。
但是我没有黄。
红考一个。哎，这个不错，这个。
就没法。
你没得买。
而且是凳子还是蓝色的塑料凳子。
怎么写？给我收了好钱。爱学校了，看着我们学校的意思。不是的还好。
我太渣了，我就没有渣了，一切非常的完美。
每一年都是这样，所以我的课就调整。
真好，我跟你讲，那个教导老师觉得我们这3个月就学3个课就行了。我们未来2周还有2个大的课。他说20号我们这个课考完了之后，就没有别的，没有别的事情要做了。那我们其他的3个其他会是？
应该不用怎么准备。
真的吗？
真的。
好。
我得会做花式的。
好，还是要准备一下。
准备一下可以，但是就不用太紧张，应该还好。应该我31我时间，怎么做就简单。你先挑战一下。应该很难吧？我觉得很难。
好好学习了。
我觉得很难。我应该从来没有尝试过挑战过，在我这么多年教学生涯，没有人记得成。应该有一个人可能在 drop out the class， 他就实在是。不太来考的话，他不来考的话，我不管了。他不来考的话，出席这样一些东西，我们来准备。
真的有点，我们都不知道从哪找。
六其实有60到medium。我不知道 computer science， 我给这些，我能给多少就给多少，这是 maximum。我再给的话，我需要写很多 report 的，这个是 maximum， 我给别人。
没有。有点尝试在上面。
最重要是你需要学到东西嘛，基本上把 Python 学好，知道好回归的跑出来，好 random forest 好 version tree 的好来着，那就我觉得我已经很满意了，至少 OK。在 ChatGPT 搜一下 ，OK， 他的谁？你明白他的，你只有明白 OK， 为什么这些跑 OK， 我明白了，我见过的，以前我去做过，然后我就很满足，就是还跟他干。怎么会发呢？发了，你去看一下。如果你哪个不会做的话，你可以那个应该会做的，对吧？没有啊，没有教了，我教的可以。 我教你这门课已经超水我真的。这门课真的是我教我这个学期教4门课，这门课只花了我最多的时间。教了差不多这一门课我就花时间教这门课。会员我出来这3年这个结婚这个会员足够简单，好的，谢谢。但是看成是有会员，对外面的。
这才是有水平吧？
不能太慢，又不能太水嘛，或者1加1。
这
开卷的，
就是可以在大家看的还是在
随便指
随便指
啊。我的建议就是你把话费本做了，
我把它
带来，带过来，应该有带一些笔，带一些 slide， 应该就有7、8成的保证。
真的这样啊？太安心了。
而且最后2成就看你自己了。有沟通，我们上课讲的最基本的东西，我没有讲，都很基本的东西。
就不用9推是。
你可以弄啊，没什么。
不是，就是它不限制招生。
没有多少，whatever。不能给电脑是因为
我给电脑
发
查一下，
因为前面有15题包括 choice， 都很简单的，这一看你就有答案那种。不能记到发生什么事情。没有，应该没有计算。很简单的。不难，我希望简单一点。因为我觉得很难，你或者跟这个风格已经够快的关系。
确实，每个老师都有这样的觉悟就好了。真的。
不是吧？因为我也当了学生嘛，对吧？
是啊。
我也不想你们太过，虽然你们所有东西但是不想太累，只有其他老师意见，我听话，我会正常一点。
对。那个确实也是为我们好，希望我们学到更多东西。
经济学课程，我的老师说 less is more， 不是 more is less is more。你教这个小的话，其实你集中精力教育的东西跟学了，因为最后还是你工作也好，我教作业也好，只要去做只教而已的，不用搞什么，对吧？等于学了武功一样，对吧？学了什么18教没什么用，泰拳那种折击拳搞定了，你拳够打就是，对吧？或什么大力出奇迹，不需要什么的，一教就搞定。哪去都统一教嘛，哪去都统一的教的。而且我教的东西就是 prepare guide for the class。对，没有读，如果你没有读的话就没什么，真我听。Bring you to there, then you know what's going on。Yes。我就不学嘛，现在人我们这门课意思没有，就是学完就差不多。
我就把它给让我
看一下吧，再打印下来，好好作业。
挂，
开卷有题。whatever 啊，你可以打你爸妈的照片啊，男朋友照片没什么，小孩子都可以。
你的照片
会有黑白的，那就可以了。彩色的，所以对，黑白的不太吉利了。
可以，因为开始我老师的书是
说一下这个题目，我的有限，稍微难一点，还记得来找你啊。
反正看过，我还没看过他的。我真的该
最好是拿出来。
那我也不知道。我想有那么一点，对吧？
我觉得猫会超有along with it， 稍微。我没有代码，我可以打2个人头，要回答。会员所以不用带电脑。
不用不写代码。
代码已经给你了，代码的结果一样一样的风格。
好。
所以不用写代码了。
好。
作业做了吧，还写代码干嘛？
就是啊。
对。
哎，我不是电脑上的。
手写，不用写的东西的。给你1个小时都不 expect 你写很多东西。我已经跟题目一样，就是空的地方给你写了吧，你就写在那边就好了。不 expect 你敲个那个空格了。
带什么接入？
普通计算机就好了。
而且还教语纲，你还教一个纲，
我
有那个是。
哇，对啊，我是经济学家嘛，我是 P 的方面噻。我不是搞 AI 的，我是搞经济的，所以我是 Ph.D 的，我是教博士班的微观的，我是做微观的，不是做的东西不一样。So the question is how many you have to give? Yes, everyone have 2 minutes and that's it. Okay, if the group have 4 person, 2 minutes for each. Okay, so just make it very concise, right? Look at the TikTok or YouTube short, right? 2 minutes is long enough to say what we want to say, right? 2 minutes enough, right? Look at the short video, right? It's not 2 minutes enough. I don't expect you because if I give 3 minutes, we have to stay after. 2 minutes only the time everyone can go home on time, right? Yes, everyone do it. 2 minutes. Everyone do 2 minutes. I will bring the timer. Then after 2 minutes, then other guy. Okay, everyone only have 2 minutes. I will strictly enforce the time limit because otherwise no one can go home on time. Okay. And as I said, you will be voting for the best group and also voting for the best presenter. Then the best group and best presenter will get some extra credit. Not the first one, but the first, second, and third also get some extra credit for that. Okay. If you want extra certificate, I can also produce that, but that will be, you will know you get it. Okay. You'll be notified you get it. You will be using handwriting. Unfortunately, I mean, it would be better to, but we don't have the code, so just write. There will be multiple choice. You can just write down, right? And there's some question with short answer. Also write that down. So it shouldn't be very extensive writing. Presentation, just 2 minutes to present what you want to doing. Right? Say, for example, when you present, you just tell me, right? The main thing is what is your question? What's your answer? The 2 things you reply, right? And then if you just do your own 2 minute thing, right? If you have 2-person group, then you tell a little bit more how you do it, what's your data, right? right? You don't need to give me the detail, but it's a business level presentation, right? Suppose your boss asks you this, how you present, right? You don't want to present in the regression. Okay, this p-value is significant. Yeah, look at the other specification. Just told me the very final result, single thing, and that's it, right? Because we are business. This course is provided business school, right? So it's a business level present. Okay, so I hope that makes sense. Don't present things that is not very good. And also, I think is try not to present with your phones on. Okay, so that's not good. Okay, that's 2 minutes, so try to remember it. Try to sound natural. Okay, not remembering. Seems to talk to people, right? If you can present without PPT is also fine. I mean, if you can think you don't need visual A, it's fine. You can just tell, okay, this is this, and I have done this question. This is what I do. If you don't have anything to present, maybe just your title and that's it, right? You don't have to use the PPT, right? Just like right when Steve Jobs, right? When they present just one thing, one letter, right? And that's it. Right? You don't have to, because 2 minutes is not very long enough, right? But you look at how people do TikTok, right? Short video, right? Then you know how to do it. No Q&A, don't worry, just 2 minutes and that's it. It's only your talk. I'm not going to ask any question. No one ask any question. Just your pure talk. Okay. Is that okay? I hope that's fine. You're presenting, okay? It's not grilling you, okay? It's not interview. Is that okay? So everyone expect to talk, okay? And as a business, I expect you to dress business casual. Means maybe most of you are okay, right? No sandals, all right? The standard one. I mean, you know what's a business casual, right? Not business formal, business casual. Okay? The standard one will be fine, right? I don't expect you to dress very formally. No, but somewhat normal, right? You expect you go to work, it's like that, right? It's not like I have a dress code, but it's like you dress better, you improve your persuasion, right? Oh, not Tuesday. I mean, it's Wednesday. Hopefully it's okay. Oh, yep, that would be good. So yes, there's a confounder, there's conditioning, and also important is this how to do the average treatment effect, right? Because you compare different treatment, that is very important. The potential framework model. The speed is okay so far. Okay, you can follow, that's fine. And do remind you that today's class is not included in the exam, so just sit back and relax, or you can do your homework, whatever. 2 minutes for each group member, okay? And probably you ask me how we do it. I think what we'll do is we will do a random number generator. Next class, say this is the thing, then I will just draw. I just draw over that. Okay, maybe I say the random number is 12, then the 12 will come out and present. No, I'm not announcing it, but just I go to Google and draw the number, or we can do a Python to draw it, right? That would be fine. Okay, that will be draw it. You can write the topic there if you want, because people can look at what you're doing, right? And then probably you can tell when you present, you'll tell you which one in the group, because people vote for who you are. Before you talk, you tell people who you are, right? Because then you can, that would be fine. I don't know whether IT or IS, but that would be the thing there. Okay. And what else? Yeah, hopefully you're right, but doesn't affect me anyway. I'm not teaching tomorrow, so hope if you have a job for tomorrow, then hopefully that's holiday. Okay. So I guess we can continue our journey a little bit. So the next chapter is about the regression and matching with observational data. So the main idea behind is actually is this guy. The problem is this guy, because you only observe some people here, some people there. You want to make sure that this is comparable by controlling something. So that is the regression is doing. Okay. So, but you will see in detail how we work, but let's see some example. Okay. The idea is, okay, we want to control, right? We have said, right, if they are bad conditional, this example, you shouldn't control, right? If you remember, the no is this guy. Is this 3? Remember, this 3 you shouldn't control, just to make sure that this is the very important graph, right? Because when you see this, you shouldn't include on regression. And the main problem is this thing, how we can do it. This co-founder. Okay, this is a co-founder, this graph. How can you handle those? Okay, so that would be the idea. Okay, so there's endorses variation. Okay, how can we handle those? Okay, so that is the part that we try to do it. Okay, and there are three ways. One is called controlling confounders. You run the regression, put them in the X, put the right hand side, then you're done. Okay, if you do it right, then it's okay. The other is called exact matching, right? That means that when you try to look at, say, master program, right? You compare people who got a master to people who don't, right? But you worry about other factors that are affecting your regression. Then you try to look at the data in such a way that look at people who do the master, look at which school they are coming from, how much score they got in the Gaokao, how much GPA he got, and look at those who don't have the master, look at the same condition, and you match them 1-to-1, then it's called exact matching, right? So that is how being done in this way. Okay? We talk about how to do it. And the other, this is very advanced, is the idea that you try to match by propensity score, means that you come up with a model that try to estimate what should be your control group. Maybe 30% of this guy is your control, the other guy is Matthew. Okay, maybe A guy, Mr. A, take the master program. Okay, and Mr. B, C, D, E also doesn't take a master program. But there's A is different from B, C, D, E in some of dimension. So you create a Mr. X that combine B, C, D, E. How you combine that? It's called the propensity score. So it's some way to combine your control group. Okay, I mean, don't worry, just give you the idea how we do it. Because if you really want to do it, you need a further study. So just give you a very rough idea what's going on there. Okay. And one of the very important thing is, in order to do causal analysis, you have to think in the ideal experiment. That is very important. Is consider a case where you can do whatever you want. Okay, and ideally, okay, and what you should do. Okay, say what kind of intervention you want to do, who is treated, who is not, and then you can try to see the data. So just think whatever you can do, right? You're available to you. How do you solve this problem? Okay, and you can try to see what the constraint in the real world they are, and then see what can be done there. Okay, so this is for experiment. We look at the following question, okay, which is often studied in finance or economics, is in Asia, very often, a lot of the firms are founder and family owned, right? In the US, it's slightly different because usually the family would delegate it to professional management team, right? So the question is really like, okay, is it family-owned business is actually better for quality or worse for quality, right? Because it's very often, right, very smart founder is able to keep it goes, right? Like Elon Musk, right? He's very smart and he owns the company and usually do better, right? But sometimes you really need a professional guy to be there to handle the job, right? If you are just giving to the second generation, probably it's not going to work very well because they may be son or daughter of the owner, right? They may not be very smart enough, right? Or they fight each other, right? Because in the family who fight for the control, then you don't really know, okay? So that's a problem, okay? Whether it's better or not, okay? The ownership. So you can see in this experiment, it's very simple, right? The thought experiment will be, look at all the companies, okay? And we can randomly change them, okay? Take firm A, it's family owned. Let's change it to public owned, okay? Managed by other people. And pick some company that is not managed by the owner, make it only managed by owner, right? You can do this. If you can do it, then we're done, right? So if you work in this way, then we can do it, right? But the problem, of course, this is not feasible, okay? And how can we do that? Okay, how can we do that? Okay, we will see. So just to recall, okay, what are good, what are bad, right? So remember the graph, these three are the bad and these three are the good. So we need to control it. So we have seen that already. And how do we do it? We have the directed acyclic graph. That's what we drawn, okay? And to estimate that, ATE, and sometimes we have to do ATET, but if you're random assignment, you can do that. Otherwise, you have to rely on that. Okay? So that means that if you are doing the IT experiment, you can do it, no problem. But you have not, then you have to be very careful. Okay. So here comes to the data, right? So remember this well management survey we do in the very first class, right? And these observational data, and then we have the management score. We want to look at whether family or founder-owned company actually perform better. Okay? So very important, you can see here, if I just want to do the prediction, I just want regression, done. Machine learning, done. But I really want to see if this has some impact there. So how can we do that? We have to draw a DAG, the causal map. Okay? And think about what are the variation. Okay? So this is the map. Okay? So here comes a complicated stuff is your family owned, right, affect this quality. You want to establish whether plus or negative, right? So this is the complicated thing, okay? And competition can affect management quality, right? Because if we're competitive, you will be better managed, right? But competition a lot then also affect whether it's family owned or not, right? So that is, and also how old the company is and how long the company has been, right, would affect negatively the family owner, because people get older, right, or get bigger. It's not easily owned by family, right, because usually go to public, right, and they get older, and then the founder getting older, right, so it's a little bit different, negative, right. And if your quality is better, your firm is larger, right, and also you survive longer, so it's positive. And then is it family owned would hire more manager or less manager, better manager, and also affect the quality as well, right? And also when we have complex technology there, then unlikely that will be family owned because it's very complex, right? So if you delegate to family, they're not easy, right? So if you're casino, that's easy, right? Because you don't have high tech, right? But if you are your company is like computer high tech, then it's very difficult to be family owned. And also depend on family circumstances and other culture, right? So these are the map, then you hypothesize this is the sign, but the main thing is this question mark. Okay, so this is the map come from, we figure out that. And why this is true, we can look back how they discuss, but I think we can start from here. Okay, this is what we know. Before that is more economic, so I just skip it because we're not economic class, but this is the value we have. So the important part is, given this, we want to see this one. This is very important because it tells us what to control, what not to do it, okay? So this family circumstance exhausts variation, right? Because whether the family the owner have a son or not, or daughter or not, right? Is something you can't, it's really, I think it's out of the question of the management quality, right? It doesn't like, the firm is good, you have a kid, probably it's far-fetched, right? So, right? And so you can tell, should you control this one, right? Ask yourself, right? Exhausted revenue, probably you shouldn't, right? So you don't have to worry about this part, right? When you run the regression, you don't have to collect the data whether, okay, this family is big or small, have son or no son, how many sons he has, doesn't worry about it. Although the gossip is very fun, but you don't need to worry about it in regression, right? The second was competition, right? And this affect both, right? So you have to control it, right? So we have to look at the industry, whether they're competitive or not, right? If you don't control it, then you don't know, you forget about it, then you have a problem. So it should be part of your control, right? This is the control that you should do. The third one is culture institution, right? Whether culture would change, whether people want to own the family and how the management quality, right? If people think that the family should own the business to manage the thing, right? And if outsider, you can just deal, right? You can just lay back, then you affect the both, right? Negatively, right? So that means that you should also control that. Okay. So this is also the country effect there. And technology also the same prototype, you control that as well because they affect both. Okay. And you will see this is a problem when you have the mechanism of reverse causality. This is the part that is the most complicated one. When they cycle, right? So this is the part that require a very difficult technique to do it. Okay? This is the part that is the most complicated, okay? Because it goes the other direction. Okay. And the other one is the manager, how good they are, right? Okay, that will be done, right? So that is the part that we don't control because mechanism, right? Because how good they are, they hire which kind of manager, then affect, right? Because in the middle, you don't control that part. So the only difficult part is this guy, right? Because now we know what's going on here is you would not need to care about this. You have to care about this, care about this, care about this. You don't have to worry about this. And this part is complicated, right? This part requires some deep technique here, but at least you know you can forget about this, this, and this. You have to control this too, right? So that's how you run the regression. Okay. But of course, at this part, the age, you have to be think about that. But we know, this is what we know, right? So basically, when you draw this diagram, you basically pretty know much what to put in the regression. I hope it's clear why we're doing that. Okay. And this data, okay. And okay. And the thing is, you put all the things you want to control, and then run the regression, then we're done, right? This is what we call control confounder. Say the Z1 and Z2, right? Maybe are this number, right? This is Z1, Z2, right? Z3 here. This is X, right? This is Y, right? So as long as you control this thing, then the regression will be good. Okay, so you control them. So this is the good part. Okay? You can control them. We've seen that. Okay, and when they run the regression, then you're done, right? Suppose you can have good estimate of those, then we are done. So this is the first thing we should do. The second thing you do is you don't run regression. Okay, it's very simple. You just accept match. So you look at feature Z, right? Look at those who do and those who don't, just take a difference. What do you mean by that? Go back to this example here. Okay, you don't run regression. What you do is, the simplest thing you can do is, this is the X, this is a Y, right? And you look at firms are family owned or not, look at the quality, okay? But you do accept match, which means that, say, you look at culture, say, suppose you look at China, only focus on China firm, you take a difference between family owned and non-family owned, you take a difference. And look at United States, control United States, you take a difference. Look at Brazil, you do the same. Okay, so this accept match, right? So basically figure out the data by taking a difference, making sure that the same, you take a difference, and this will do what we want. Is that clear? So just you compare and contrast, you match this firm to the other firm, the same. That's how you do the matching. Okay. Now, of course, this is doable if this covariate Z are discrete, right? You can easily match. But very often, you're not. You will do the coarsening match. You match something similar, right? For example, you can match McDonald's in China, right? And compare to something similar in China. I don't know, McDonald's similar to 风行包子的 then it's similar, right? Then you can do that, right? Or in the US, maybe you compare the McDonald's with I don't know, Wendy's or whatever. They're similar, right? You can compare, right? But if not, then you would just have to compare based on other characteristics. Okay, that is called the Causal matching. But I will not go into detail because even the book don't go into detail. Okay, so I just skip there. And the other two is actually we call the propensity score matching. And the idea is we do a logic or probit on whether the firms are family owned or non-family owned, right? So the idea is like, I look at China, say, I look at some firm that is family owned, right? And then I look at characteristic. Then I want to look at, as a comparison, I look at other firm, okay? Is also have the same characteristic, okay? The Z, okay? And that gives a score. And I try to map, as a comparison, look at those company, okay? So that come with that. I guess is, I just very brush here. Only thing you probably in your mind is there's some way to do it. Okay, I'm not going into detail, but because this is way more complicated than I do, but I tell you how to do run the regression, you can do it. Okay. And so, and very quickly, like this is the interpretation, right? If you try to see, if you run the regression, just look at not just run the simple regression, just family owned and management score, and you will see that management family owned the company actually have score lower, right? It's 0.3 lower. But if you include some confounder, right? Confounder, as I said, is like culture, business, competition, all this variable, then you go down. Okay, so you control them, this actually goes down. Okay, and if you interaction, then you just further go down. Okay, so that means that, right, the confounder is actually affecting, right, whether you are family owned, right? So that is the idea that why we have to control those. Okay, because look at the graph again, right? These affect them both. If you just include this, you tell 34%. Right. You tell that having an owner, the management quality dropped by 0.34, right? But if you include this confounder there, how competitive the market is, the product type, the country, then what you left is 0.17, right? So that means that you can tell, okay, if you believe this graph, that is what you identify. Okay, so that means that you shouldn't put in this one, right? Remember, this one should, even though the data is not put there, right? You don't put this guy, you don't put this guy. Okay. So a very quick go back to the very at the end. We know how to solve this, and this, but not this guy. Right? This is not solved. Okay. So at the very end, we talk about here is what we call, there's one technique that is something that you need a PhD to understand. It's called IV and regression discontinuity. These are all the two techniques to solve this problem. Okay, so these are the two particular techniques that can solve this particular problem. See, how do you solve this firm size and age problem? Okay, if you have this kind of problem. So IV is the idea that you have this problem, right? So you want to have figure out the IV that affect this one, but not affect this one. So the idea is like this. It's actually very simple. You draw a graph here. So you can see that IV is, if you can find something like this, I affect this guy, yes, and not, right? If that's the case, then you find this out, they can ignore it. You figure this out, then you're done, right? Things that affect your firm size, things that affect your age, right? But not these two, right? So if that's the case, then you can establish that, right? And what might be there? Suppose maybe the government subsidy, suddenly a large amount to this company, right? Maybe government just print money, okay? And only print money to young firm, not old firm, right? Which often, right, support the young company, right? In that case, you control that, then we're done, right? You believe that the money by the government doesn't affect this thing in one direction, then that is how you do it. That's called IV method. Okay. They call instrumental variable. Okay. The other method is called RD. Okay. Is what we call regression discontinuity. Okay. Is coming from administrative rule. Okay. And very interesting example, you will see a lot of study will be like this. Okay. Is the following. There are many study in the economics that they do this. So this is X, maybe Gao Khao. Is it K? I don't know. Right? Gao Khao, 成绩. Okay. And then you look at 高考成绩就是 then you have to cut off, right? I don't know what's the mark there, but suppose 500. I don't know what the number is, but anyway, you will see, okay, that means that these people got admitted, right, to a program. The other is not, right? Maybe you can say GRE, right? And these people are get to the program, these are not, right? And then you can look at, say, suppose I look at our master program, okay? And look at the people who just got in there. Okay? Look at the people who just got in, because about to cut off, see how much money they make. Okay. And I look at the people who just below the cutoff. Okay. And then if I look at the case somewhere around people who just got admitted the least capable person in our class, okay, and look at the best who just cut off, okay, if I can see a difference between how much they make, okay, and that would be the impact of the master program, right? Then actually people look at this is many studies look at people go to top 2, make this money, and people were just below the cutoff of the top 2 which they apply, and that's we look at how top 2, right, contribute to your earning. Okay, this is an actual study, not my joke. These people actually did that. A lot of people study that as well. There's a because of that law they dictate certain thing, and then this law create this continuity, and this will allow us, right, to forget about the ability, right, because we think the ability we cannot see, right, somewhat go in other direction, right, but the ability between the cutoff will be very similar. So by comparing the cutoff before and after a little bit, then you will know, right, what is going to be a difference. Okay, so that is called regression discontinuity, but I'm not going to the detail of it because even the book doesn't include it. They just mention, oh, there's something that can be done. So that's why I just want to mention that there. There's a lot of here, but before the break, let me summarize what we have done so far. I think we have too many stuff to cover already. Maybe you would be in your head, but I guess the main thing is this diagram, right? Tell you how to run the regression, right? The simplest thing, right? And to recap is you would include this guy, you don't include these 2 guys. Okay. If you run regression, then you forget about this guy, then you still get a lot of mileage from there. Okay. And this one you might or may not include. Okay. If you think this is a very weak link there, you can basically, I think this is the link is not very strong, so probably you can forget about it, right? But if you think that this is rather strong, then you have to figure out how to handle this question, right? But usually this is not a big deal, then you're done, right? And that would be the thing, right? Because where you can see it is assumption on this guy. Okay, but otherwise that is a regression problem. Okay, and of course I say regression, if you want you can do LISO or other thing as well, right? But also usually in the causal analysis we don't use machine learning technique. just simple regression and then that's it. It's sufficient, right? Because we want to see how they're related, right? Whether the coefficient, we want to see the p-value, is it less than 5%, and then you're done, right? And then usually we establish first they're related, and then we can go further. But usually this is the part where you stop. Okay, I hope this gives you a good idea what's going on. Although we don't have time to cover everything in detail, but I can reassure you that basically, if you go to PhD program, this is you spend 2 semesters on this thing to do how to do IRE, how to do ROD, how to do the causal map, how to estimate. This is we spend 1 whole semester to study all this thing. Okay, so that's why we can't do all the justice of all this, but I hope you can look at the example, look at the code if you want, but I guess it's not main big concern for you because your IT manager, usually the good thing is you control what the changes. Okay? Then you can do ATE, right? Then you don't have to worry about it, right? Because AT is same as ATET, right? Look at, you impose the changes to your group, then you're done. As long as you randomly assign, right? Then you're done, basically, right? But if you're not, then you have to worry about that part. Then you have to slightly more complicated, right? But run the regression, we learn once we draw the map, run the regression, we are done. So I hope that would be okay. So after the break, we will try to give you some idea of the 2 important techniques, just very roughly, about difference and panel data analysis. Just a very rough idea what's going on there. As I said, even panel data will take a whole class in the PhD program, or even undergrad, right? Or difference, if you do it right, also another whole single class. So I can't do justice of that. Just I can only give you a very brief overview on those. But let's take a break of 15 minutes and we come back. Then we see what to do. At the very last moment, of course, I will open the uReply again so that if you want to, I guess it's the only last uReply, unfortunately. I mean, next class, you do uReply, but not on me, on your classmate, right? To vote who's the best, who's the worst. But otherwise, I think this is the last time we do you have fun with the uReply. So whenever you want to complain, want to say anything, want to share. So enjoy. I'll see you in 15 minutes time. comment 也不留言说，对你不懂的话可以问问题，就说做不是，因为我知道你不记名的嘛，我认得你的样子啊，没错。就找最近答案，不然今年我都说不考，MC 不考计算，MC 不考计算，应该是不考。是问你一些问题，比如说2square 是干啥的，特别是如果我要算这个 data 在哪里，我应该用哪个东西啊 ？A B.B.A 是可高是就是一看就来，不用算。这个比较难吧？你们算不容易一点吗？一看就答案不容易一点。的问题，比如说现在有什么好处啊？为什么我们用到 force 啊？或者为什么用 regression 啊？这个东西。我应该是 MC 那不考试，我再看一下，应该是我应该是没有考试。 啊，
有点迷呢。
这比较难吧？还有计算，我觉得容易一点就是看人家答案，轻松一点。行吗？这个比较还有算呢，我这是不用算，你看知道了。
我也想说，一是给我时间问题。对，然后我现在真的很讨厌回忆的。我觉得他的一分上学期半程，下一个方面半程，那个分配其实非常合理。对，就加上他如果学的这两个太应该了。是，这一个学期东西正常的1年4个月。我还在，我真的没想到我上课那个。我觉得那个就是日本发现，我感觉我室友的课也不闲的，就是没有在。我下面一个是allocation的，一个是英语的，不懂的那个。就是其实我真的allocation这个东西，你知道应该把那个在不对。其实我就只是另外他。对，你要跟我讲这个同学，但是你看这个，这还是用到假的，那个是他就是可能天天回忆，要么说回忆，不然就是说，好像你说。那 sorry 好吧 ，sorry，那又不是。我反正不会说任何什么高考这种拿个分。我以前后来想，然后我现在想，外卖实在是不太好，确实。我就抓紧微信，这里也没有别的办法，就老是这样。这个好像是老师的早上，太早了。我真的很希望，而且我后来一直在分享。他给我电话，他多给我2个钱。有多少是这个吗？那我这个有学我能多选择30分。要看他怎么样。你当初谁学的好，最后考招我不要你了。 放松了。OK，有点怕。我用我。那个手往哪拆？可以。这不是一个是这个管的那个。有。但是不差这几分，那他给3分嘛，咱还背一个人了，你看在这里打，那要的不是这么一个人，那要的是过的。对 ，OK， 知道吧？他不给分，咱们说不给分。我刚刚对吧？对啊，那咱们俩对。哎，但是我跟他俩对，那我就选择对。那你能把你答好，那就可以。我不想打开了，我觉得第4题太难了，那就写那么4个那个就是可以。我觉得那个那就行，那就可以吧。我自己有办法。哦。然后我又搜了一下，我又做出了一个。这9期我其实就是在那个什么，因为我觉得price那个。我觉得他的这个翻译吧，让谁他都不行吧。但是光是那个 B 的话，我猜他是不是可以翻译吧？所以应该是我也其实我选的D，反正这第10题可能是 C 的。我一开始哎。谢谢。对不起，这个看到都是 A， 是不是？我看一下，对呀，就是我写完了，来不了看吧。我大1、大2、大2 不过确实我当时也觉得，突然变得有点，那你们一点道理。你这样没有人讲。我觉得他可能有点不会讲，他没有 TA 吧？他有 TA 吗？他不是，他有 TA 吗？他这种好像，他这种好像没有 TA。不是没有人取消的，他作业不是好的。对，不知道咋弄，他没有看到那个，不感觉那点这些的。不知道别人快手怎么样？外头玻璃，对，那个没有伤到那上就会。差不多，看着。
就看点图上的。
对呀，专门对呀，你只是越说越而且加了本身职业不需要强制我，其实又不是那种。
See the question. Yes, unfortunately, due to my limited ability to control your computer, so we just only allow paper. We have exam here, but we can't use the computer. So just bring whatever paper. There's no limit to what paper you bring. Okay, as I said already, whatever you can bring. Okay, but you can't share with your friend. Okay, just use your own. Unfortunately, no. I may wish to teach this class because you guys are excellent students. But to be honest, I mean, we really enjoy teaching this class. We're happy. I mean, so not a just very good. I mean, I would happy to teach, but unfortunately, I already reached my limit to teach. I can only teach 2 classes for the master. Usually, I teach another undergraduate class. I also teach another Ph.D. class, and also these 2 master already reach the limit I can teach. But I wish you the best for the upcoming 2 things, 2 presentation, also the other. I hope every best for you. By the way, I'm also high in RA. If you want to work, then you can just let me know. I mean, I have a part-time position and also have full-time position. So after we can talk, I mean, see if you want to do things. I'm very happy to it because I think this class is amazing. So I just put it here. Okay. Just within this class, okay? Not okay. I just what I said, okay? Yeah, so I hope you understand how they're related, what you should put in the regression to control. Of course, as I said, this is the causal relationship is so complicated. It really requires PhD level to do it. But that's the case. Oh, by the way, one thing I probably want to say as well is we're also hiring, admitting PhDs for our program. So if with deadline of December 1st, if you want to continue to do PhD, probably you can, because PhD will be talking about those things, right? If you want to do further. And I think in the past, we have been admitting 1 or 2 students from our master program to a PhD. So in case interested, I do economics, but if you do want to do management information system or operation management, feel free to apply as well. I do economics, I do theory, and also do empirics, I do experiment. So especially if you want to do experiment or do theory, then probably will be a good match because I have a grant to do those things. Okay. Sorry for advertising, but and yeah, I think it's okay now. I mean, I hope everything is all right. Yeah, I will be here. So unless things happen, you can come back and talk to me because my office is just opposite the ITM office. So whenever you go there, then you will see me opposite there, unless I kick out from that office to go to the other one. But oh, that's a good, funny question. I'm leader of 6 members, a trip with a budget of 300 for the whole day. Now you die for roast chicken to eat. How much money will you pay for the roast chicken at most? Yeah, I think it's okay. If you really like the roast chicken, but I guess Hong Kong roast chicken is not the best, right? You use the roast duck, right? So I think you should spend money on the roast duck. That would be more famous. Or goose, but I mean goose cannot be 300, right? So duck may be okay. The other one thing is sardine. There's a very famous roast dove, 鸽子, 鱼哥, right? So that is something in the sardine Dawei area. You should try. That's 100 something area. So you should try that. Yeah. So wish you the best. I hope you learn something from this class, and then the minimum is to learn how to do Python. You run the regression, how to read the table. That is what I'm asking, right? If you look, I mean, I guess I don't know. Maybe, yeah. I guess the time, probably I should talk about the past paper, right? Rather than just go to the thing. I'll quickly go to the past paper, right? Because I think that would be, because although I uploaded, some of you actually don't know where I upload it. Ask me where the paper is. So I quickly go over that before I go to the final thing. That would be, I think it's more, time will be more best done this way. So it'll be very similar as 1 hour. And the thing is very similar. We have open assessment, bring anything, calculator, but do not Wi-Fi function because, and then I think we have a 19 pages or 20 pages. And then we'll be, I think this year I have 15 MC question, but this time the question is easier. Okay. And we'll have, instead of 4, we only have 3. Only 3 questions. I think it's only 3 questions, right? Somewhat like, I think it's 3 questions. Yeah. Yeah. I think something like first question like regression. The second question is more like the LISO. The third one is like random forest or regression tree. It's just like 3 questions there, something like that. And I think the multiple choice is something similar. But I guess I think last time people spent too much time on calculating that. So probably you don't have much calculation to do. Okay, will be very straightforward. Something like question 4 or question 6 or 7, 8, this kind of style. It's more like you read it, you know it, then you're done. Okay, that means not something like you have to think too much, something like 10, something like that. So if you know what's going on, that should be done, right? And the long question will be something like that. I give the code, okay, and give the output. Then you try to look at the output and do. You don't understand how to use it, then you're done, right? So something like that will be something like this question, but this slightly more complicated, okay, and will be logic is gone because I'm not. That is I put it technical, right? So it will be something like this LISO thing, right? But probably something similar, but it's slightly more difficult, but more or less along that line, right? And the regression tree or random forest will be this or similar, slightly more complicated, but more or less along that line. So somewhat, I mean, this is something we're asking, right? So we have been, these are the things I have been teaching, right? So that's I will ask, okay? And this year, I've been talking more about how actually compare different models, right? So this is part that I didn't talk too much last year. So it will be somewhat like this. I'll ask how you compare different models, right? You can based on AIC, BIC. I just ask where. These are the added new thing that I would ask, right? Because that is thing that I've emphasized on this year, right? How to run the race, right? Do the CV cost validation comparison, right? How to do this kind of thing. But other than that, it will be very similar. Okay, so you will not be surprised by the question I give you, right? So it will be no surprise. Okay? It's 1 hour, so don't feel bad if you can't finish. Okay, it's by intention I make it. You can't finish it in 1 hour unless you're the very top in the class. Okay, so it's like British style. Everyone is not supposed to get more than 80 marks, right? In British, right? British exam, right? If you get 70 something, you get an A. So this kind of idea. Okay? If I give you 1.5 hours, I think everyone can do it perfectly. Or I just give you 1 hour under the time pressure and see who know what, right? Yeah, quickly. So don't worry about that. I think everyone will be okay. We'll be fine at the end, right? So is that okay? Any question? I hope it shouldn't pressure you that much. Okay. Okay. So finally, I want to tell you 2 other techniques besides IV and RD. You will learn DID, diff and diff, and panel data. These are all the techniques that if you try to look at, okay, if you run causal analysis, okay. And diff and diff is very simple. Let's see what we're doing, but this is just what we learned in the control experiment. And panel data is like your raw data. You try to control the individual difference. Okay, but let's look at DND. Okay, DND is very simple. It's the idea that you have 2 groups of data. One group is affected, the other group is not. You look at 2 periods, before and after, right? And then you look at the control group, look at before and after the difference. Look at the treatment group, before and after. Okay, so both groups have before and after. The difference between the difference before and after will be the causal impact. So that's quite a different diff. The reason is the treatment group difference before and after is not the end of story, because the difference within the group is the treatment, also the background effect. Right? The idea is the following. It's very simple. So you look at, say, how much people make, okay, before they get a master, after they get a master. Okay. And look at the case people who don't have master, right? This year and last year income. Right? So but the fact is, you look at the people who make money before the master, after get master, right? The time difference, right? economy may be going very well. So you have to take away this macroeconomic effect, right? Or you get over the age effect, right? So that means that you have to look at the control group to see how they change, okay? So that is called the background effect. So by taking a difference, okay, you take it out, right? Because the control group before and after is the background effect. And look at the treatment group, the difference is treatment effect plus background effect. You take the difference between this over the difference between this, you get the treatment effect. So that is why we call treat different and difference. Okay, the idea is like this. So each observation difference is a guy I after the treatment and before the treatment, right? The treatment is the, say, you got a master degree, say, for example, right? And the problem is, if you can control before and after they're the same, that's fine. But usually before and after you measure a different point of time, right? It's very difficult, right? Just like even the medicine, right? Your body will self-health, right? You have the white blood cell and all the thing, right? So your body will recover even though you don't take that medicine, right? So you can't control that part. So that's why if you look at the treatment group, you have the treatment effect and background effect, right? If you look at the untreated, okay, only background effect. So that's why you take the difference, okay? DID would be looking at the treated effect, the difference, then you get what we want. This is, maybe I just write that here. This is equal to the difference y untreated, right? So you take the difference between the two, left with the treatment effect. Is that clear? So that's the idea there. And this is the current, if you want to do causal analysis, I think this is 80% of the study based on this one. So this is the technique that's so commonly used. Is basically I think it's most of the people will use that one. Okay. So it's very simple. You just run the regression. Okay. Look at change in outcome, look at treated, the beta is the things we want. Do I have example here? Okay. So the idea is like this. Okay, the graph, right? If look at the group that's untreated, they don't have master, right? Go up alpha, maybe just because of the economy is getting better, right? And this is, if you think that, okay, they don't get a master, they should also go up this way, right? But with a master, they go up higher. So this is what you see. You subtract from this one, this is the effect. So this is the effect of the master, right? So that is the main idea of the ID. Okay. So here comes an example. Okay. You want to see this study is a USA airline merger. And probably you know American Airline filed bankruptcy. And then US Airways take over that and they allow the merge. Okay. So this is the setup. And you want to see, okay, look at data from the US transport, look at 6 years before and after. And you have a big data, okay? And you look at origin destination, means how many flights is there, okay? Okay, so that is the idea. Look at itinerary, look at how many people travel before and after, okay? And probably you want to study is merging is going to change people travel, right? And the X and Y, right? Look at data there, right? So there are many things you have to be careful with the data because as I don't want to go to detail, but just like there's a return ticket, one ticket, there's a one-way, two-way, what's the market, and then there's a many complications to handle. But you can check it out, okay? But what do we want is looking at the price, okay? Whether merge the firm together, the price would go up or go down, right? because that is actually when you go, it's not economic class, but as economists, usually we talk about when firm merge, we worry about the price would go up. If price goes up, usually don't approve. So that is the thing we want to study. Okay, we want to go back to see whether actually the price go up by 5%, that's bad. Okay, that is usually the study that we allow merge or not. This is I think in China also do the same. They have regulation. Whether allow firm merge is whether once the firm merge, whether the price goes up or not. Right. So that's the question. Merge as treatment. Look at the market before and after, whether the price actually go up or go down. Okay. So you can see, you can look at the prices that is untreated, means that they are not American airline or US Airways, right? They're a company that doesn't price, okay, it's not there. But you can see the price is higher, right? Because it's 6 years before and after, that's inflation, right? So price will go up. So that is represented background effect, right? Because price goes up because of the economy is 6 years after, right? And the set and treated, right, is actually the firm they combine together. Actually, the price goes down, right? Which is reasonable because usually when firm combine, then they would probably more efficient, right? And there's a synergy there overall. Okay. Turn out we figure out that, oh, that's funny, right? You will see this is very small, right? 2%, right? But when you take into account that the other company are increasing the price, okay? So actually, the price they actually go down by 80%. So the merge is good, right? Once they merge a company, right? Actually, the price has to go down by 10%. So actually, the regulator in the US is very smart, right? They merge it, actually the price goes down. It's good for consumer, right? So that is how we look at this question, right? So you can look at this is whether they are this company before and after, run the regression, and then you're done. Okay, this is simplest regression, but do remember that we don't control a lot of stuff, but this is the simplest we can do, right? And you run this regression, this is what you see, right? So you look at all the market, right? So this firm actually dropped by 18%, right? And small market, they dropped by 16%. Large market, they dropped by 26%. So this merge is very efficient, right? Although usually when you look at economics, you say small number of firms, the price would go up, right? But in this case, actually, the airline became pretty efficient, right? So actually, they can price goes down. They're getting more competitive. Okay. So that is understanding how the merge would happen, right? How it changes. Okay. And there's an important assumption which we can't verify on this different analysis is from this diagram we call parallel trend analysis. What we say is without the treatment, they should follow the same pattern, the assumption there. And then that's why we can subtract from there. That's what we get. Okay. And that is the main assumption that we have to make in order to figure out what's the treatment effect. And this cannot be verified. You can just based on some other background and say, in this case, a merger, we can just assume that, okay, US airline, US Airways, and American airline the price should be similar for the same trend if there's no merge. Okay, it's the same as other company. If this doesn't hold, then everything breaks down. Okay, but this cannot be validated by any statistic. You can't verify. You just think this would follow, right? That's actually the same when we think about drug tests. Okay, say suppose guy number A take the drug, guy number B, me, don't take the drug. Okay, We compare after this, before and after. We have to believe that guy number A and me are the same if you don't take the drug. Okay, this is something I cannot tell. Okay, but we believe that this is the case. Okay, if that's the case, then we're done. Okay. So this is what you see. The merger actually just go down the price, everything. So everything is very nice. Okay. And but what you can do is look at before the merge, they move in the similar direction, right? So this is the data get here and here, right? And the price seems to be in the same direction, right? So it seems to be okay. That's what you can say. And also look at the I think this one way, this is a return. This is also very similar. Okay. And the next is often is you want to control the confounder, which we discovered last time, right? We want to look at things that might actually affect whether it got treated or not treated, right? So that is why you want to control those. Okay, you condition on them. Okay, and for example, you want to control these the firm characteristic, like whether they have return route, with the number of customer, with the number of stop on the trip, right? So whether you stop layover, you control all this because the price of the ticket, you control many characteristics, okay? Because they explain the price, right? It's not affected by the merger, right? So you can control them. There's no problem there, right? So you control them, you get a better match, right? So that is why is there, right? So that is standard way you do things, okay? And I guess I want to, this is different difference, and I want to draw your attention to the panel data, okay? The panel data also is a well used in a lot of identification, and this is, I guess this is the data that for IT manager as well. So what's panel data? Panel data is basically you have individual, you observe them over time, right? That is actually IT data, right? You have a customer, the client have been working with you, and then you have data of they go to website every day, the cookie, right? The cookie, you identify who they are, right? You know this customer do this is not anonymous. Right? You keep tracking these people, how they're working. That's why, right? When you try to register the website, right? That's 实名制, right? Real name register. So you know who is doing what, right? So you can do this analysis, right? So I'm sorry that the printout in this way. And the main idea, let's forget about this crazy slide. Okay, let's go to the real stuff there. That's a little bit complicated. Let's see, time series. Okay, this is the idea. Okay. The idea is like this. Okay. If you have multiple observation of the same guy over time, YT, right? Say Y is how much he spent on your platform. Okay. And this depends on many things you want to study, right? Maybe you give him discount or whatever. And that is called the fixed effect, right? Maybe that guy is rich, this guy is poor. I mean, this is the fixed effect there, right? Okay. And your time fixed effect, right? You have this kind of model, right? And Usually, there's no hope to figure out this if you only observe him once. Okay? But if you observe him twice, 2 times, you can take a difference, right? Because like this. Suppose you have the guy, the main idea is like this. You have a guy, okay? You observe him the first time, alpha I, right? The model like this. X1t, xi1, right? You observe him second time, I2, right? Then how can you handle this? Because there are many guy, but it's I, right? There are many guys there, right? And this, you can't see it. So what you're doing do is look at the difference between the two period of time. Right? And they're the same, they're gone. Right? So left is beta xi1 minus xi2. And if you run this regression, then we're done. So if you look at the same guy over time, you can take a difference. Okay? And you run the regression, this individual character is gone. Right? Look at how they behave over time. First difference, look at difference. How they do over time, right? Then you're done, right? So by looking at the change of observation, how it caused by change in X, then identify how this affect that, right? Maybe X is the marketing effort you put on that guy, right? Y is how much you spend, right? And you put more money to advertise, right? They may buy more, right? Maybe you are the website, you're the game development website, right? You give him more credit or you give him discount to buy more weapons, right? And they will buy something, right? But you don't know this guy, how rich he is, right? So all you do, look at the difference, run the regression, then we're done. Okay, so that is very often used, right? The website, right? That's why in a lot of Taobao or Tmall or whatever, right? Sometimes they give you secret coupon. You click on that, they can discover how effective they are. Actually, you see a lot of coupon and discount on their website. Actually, they're doing some experiment on you. And then they see how well the effect the program is, and then they can decide how to set the prices, right? Because they give secret discount to you, look at how you respond, then they figure out that how effective of this thing they are. Okay, because by controlling, look at how you perform across time. Okay, this is the way to do. And there are many more things you can do, but this is what we mean by panel data. But I don't want to go to detail because I think going for all this crazy thing will our mind will get insane. I mean, because of limited period of time. So I guess I want to give you an overview of what the whole course is the remaining 10 minutes, right? Hopefully it's a good revision for the whole course. Okay. So let's go back to our, I think the best is go back to our syllabus, right? I mean, syllabus and highlight what we have been doing. And hopefully you agree that we achieve most of the objectives that we want to go over at the beginning, right? So let me clean this out. So let's see, except the very last part, probably we don't have much time to cover, but so we almost cover everything except 9 and 10 a little bit. We brush over a little bit, but I guess we have a solid understanding, right? How to collect data and how to assess quality, how to clean it, right? Because that is actually what you do the assignment 1 and 2, right? How to organize them, right? How to run the regression, how to clean them, how to clean the data, right? And it's very important. And that's the first part, right? The Python, how to download data from the GitHub, right? Or other places, how to upload it to your Colab, right? Or you want the Jupyter notebook, right? You know how to do that, right? How to recode them, how to do MP where to recode them, how to replace NaN data, right? Not available data, right? How to group the data, how to do a scatter plot, how to do bar chart, how to do pie chart, all these things, right? You should know very well, right? And then we learn mean, variance, right? Kurtosis, all these things can be done, association, right? How to look at the data, right? How to do the scattered bar chart, all those kind of things, right? We know how to do the first round analysis, right? And these are very useful when you try to go further, right? Because you want to look at the pattern and the thing. And the chapter 5 and 6 is basically the foundation of, well, to do regression, right? Look at the p-value, right? When p-value is less than 5%, then not important, right? And then how to generate data, how to do estimation, right? How to do confidence interval, right? How to estimate those, right? Because in the regression model at the end, right, you also tell us what are the parameter range, right? When you predict, also tell you the interval there, right? Because the regression line represent the mean estimation, right? And you go up and down, right? If you recall, hopefully you still remember, right? In the chapter 4 and 5, right? And then we learn how to draw this kind of graph, right? That tell you on average this is a line we want, but we will be not very clear, right? Probably you look at that is we are now is typhoon signal number 3, right? And if you look at this, it's actually we do it all the time, right? If you remember our eating example, right? If you look at this, right? These are all confidence interval there, right? Why it is not Hong Kong? Let me make Hong Kong. So this is the interval, right? So this is the mean area, right? And these are confidence interval, right? So you see that all the time. And in this week 4, right, we run a lot of regression, right? The simple regression, and the messy data tell us whether you take a log on the y, on the x, whether you take a square, you want interaction term, right? Whether you want the Lewis, right? Nonlinear regression, you have the bin scatter plot, right? And these are there, right? And then we learn how to run multiple regression, right? How to interpret those coefficients, right? And more importantly, you learn how to understand the meaning, right? Especially when you have square term, right? You take the calculus, you understand the coefficient. And after that, this chapter 6, we just basically skip the time series analysis, but give you some idea of the problem and logic. Okay? It's non-linear regression. Okay? But we don't have time to go into detail. But we spend a lot of time on this one. This is different from last year to this year because I think this part is the most important part. So that's why I spent a lot of time on this one, right? How to do prediction, right? And how to select model. Just remember how to select model. We use adjust R square, AIC, BIC. These are the criteria. And we also learn how to use cross-validation, right? You cut the data, right? Different part, and separate them in a text group and test data and train data, right? and you train the model by train data, and test the model by test data. And we are exactly how you run the Python code carefully on this one. So this is the one of the main things that you should be very careful. And the LISO, right? LISO is the way that the machine learning approach, which usually you don't learn in the undergraduates, unless you are really into machine learning, right? The LISO will tell us, you give them all possible combination of the specification with the square term you need, then let the machine pick the one that is most useful, right? So this is the part that appear in the last exam. Then if you do a prediction, then probably this will appear in this exam as well, right? It's an unbiased estimate, 95% confidence will be there, but I don't know. I mean, I forget what I have made the exam. Okay, and also important is the random forest and the recurrent tree, right? And then you can also see the importance of last year exam, right? So very likely that if you think the last year is a good best prediction, that's likely the case, right? So you will be there. So make sure that you understand the code, how to generate them, and how to interpret them, how to apply them, right? I mean, you can check the past year paper and see that has been done, right? And last but not least, today we talk about somewhere quickly the causal analysis, and we talk about how to do it, what to include there. I guess I pretty much crammed too many things together today, but I think at least you understand. When you do causal analysis, you need to draw the map. The causal map is very important. I hope this stick into your mind, although we don't have too much time to work on. But the important part is like this map. Okay. Probably this is a very good example, right? Because you know this should be there, okay, and this shouldn't be there. You can tell. And this one, you have to use IV or RD or DID or whatever to figure them out. Okay. But if you think it's not important, they can skip, right? Because there's no perfect, because you can always think of a very complicated way to do it. Do how things are related, right? Because we have a butterfly effect, right? Something changes can affect everything, right? So if you think it's not something crucial, we can ignore, then we're done. Okay. So I hope that you like the class. Of course, we spend a lot of effort on this one. Hopefully you learn something, and I'll see you next week. Next week with your presentation. I'll bring peanuts and eat while you are presenting. Hope you enjoy as well. I will have fun. I mean, I hope you have fun as well. So good luck. Thank you, and then I'll see you next week. Thanks. Thank you. Thank you. So I stay around to answer the question you may have. Have fun.